Okay, let's look at this one. All right, let's look at this situation. We want to graph y equals 3 sine of x in radians and in degrees, and it says that you can use example 1 on page 399 to help. Okay. For this one, what was the one transformation to graph y equals 3 sine of x? Well, this would be a vertical stretch by a factor of 3. Well, if I'm going to stretch vertically by a factor of 3, right, let me first in pencil kind of draw out a few points that I know for my typical sine function, right? So I have y equals 3 sine of x, okay? But if I just had y equaled sine of x, if I just had y equaled sine of x, I know that at 0, the sine function is 0, and every half revolution, right, every half revolution, the sine function will be back at 0. Okay, well, what if I stretch 0 vertically by 3? Well, 0 times 3 is still just 0. So I know I am going to have these same x-intercepts, right? If I stretch vertically, I'm not changing the x-intercepts. Okay. But what about the maximum? Well, generally, right, if I call this 1, 2, 3, -1, -2, -3, the maximum is generally at 90 degrees and the minimum generally at -1, right? But what's going to happen when I stretch vertically by 3? Well, now 1 times 3 goes all the way up to positive 3. -1 times 3 goes all the way down to -3. Right? And so what I have is this graph, right, where the graph here, right, looks very much like the graph here. The only thing is that I've stretched vertically. How can I tell I've stretched vertically? Well, it's very important that I label the axes. Here, the range from -3 to +3, that's my range of values. But over here, the range from -1 to +1, right? And I set this up. Let me draw as much as I can. So over here, this comes down to -3. Over here, it goes up to +3, and I have the graph of y equals 3 sine x in degrees. But of course, I could also talk about this same graph in radians, right? At 0, at pi, at 2 pi, at -pi, at 2 pi, right? So integer values, integer multiples of pi, the sine ratio is 0, right? Halfway between, I'm going to be a maximum. Halfway between these two x-intercepts, I'll be at a maximum. Right, and this is 1, 2, 3, so halfway between at a maximum, and halfway between at a minimum. Halfway between at a minimum, halfway between at a maximum, right? If I understand what my graph does first, right, over here, the sine function starts by increasing, then it goes down, then it goes back up, right? Then that pattern gets repeated, right? And once again, it is very, very important that you label this y-axis so I can tell, hey, the range from -3 to +3. I can clearly see the intercepts. I can clearly see the maximum. I can clearly see the minimum, right? Function increases, slope is positive. Function decreases, slope is negative. All of that still applies.